Actually, we need to review those timers that we talked about. The 3 timers we talked about. What are they?
Time on the day, time off the day, and the third.
Lieutenant?
Oh, I'm sorry. Retentive time? Retentive time?
Yes, retentive time. What do we use with a retentive timer?
Latch.
Another instruction.
Reset, sir.
Yeah, we have to use the reset. What are the 3 static bits, control bits? TT, EN, DN, yes.
Enable.
Yes. When do we get when does the timing bit get set?
As soon as it's enabled, it starts timing.
Once it starts timing, yeah. And when does the timing bit go false? When does it go?
As soon as it's enabled, or done.
Yeah, as soon as we time out, right? So it's one of those things when the accumulated value reaches the preset. When the accumulated value reaches the preset, when it's done timing out. When do we get the done bit on a TON timer?
After it's done.
Yeah, after we time out. When do we get the done bit on a TOF timer?
After it's done.
Time off. When do we get the done bit on a TOF timer? Remember? It's just like the contact, right?
As soon as the contact's open, as soon as it's they're going to close, they'll time back open.
It's just like a normally open contact, isn't it? When do we get the done bit on a TOF timer?
As soon as you contact,
When you lose electrical time,
What kind of contact is that?
normally open, timed open,
Normally open, time open. How does that work?
it closes instantly on energization.
Yes.
And then times back open when power is removed.
Yes, there you go. So when do we get the done bit?
As soon as those contacts open up again.
as soon as it's energized.
Yes, as soon as the instruction is enabled or energized. Yes. Yeah. Yeah, so the done bit actually just is active. Let me take that back. The done bit on a TOF timer. Let me back up. We have the done bit, timer time, and the enable bit. When do we get, let's just talk about the TON timer right now. When do we get the done bit on a TON?
After it's timed out.
After it's timed out. When do we get timer timing?
As soon as it's enabled, it starts timing, or your preset.
As soon as it starts timing, right? And how long do we get the timer timing?
Whatever you set it to.
Yeah, until it times out, right? And when do we get the enable bit?
It's enabled as soon as it's timed out. Based on your amount of time.
The enable bit.
It's enabled as soon as. Oh, yeah, enabled as soon as you apply power.
Right, it's enabled. It's just telling me the instruction is enabled, right? That's all it's telling me. Yeah. Everybody's good? And you're good for a test?
Yes.
Let's take that.
Take a test again. Time of time is not considered enabled because it has to close first.
Yes. Yeah. Review that chapter, please.
What chapter is it again?
7.
Only 7 or is it only?
Yeah.
1 through 7.
Yeah, 7. Okay.
Okay, then, anything we know,
Need to review it all. We just haven't covered all of it yet. We haven't covered cascading timers, enunciating timers. We'll do that next time. So we know how the status bits work with a TON timer, yes or no?
Yeah.
Okay, good. And a TOF timer. How about a TOF? When do we get the done bit?
As soon as it times back on.
When do we get the done bit? As soon as you energize,
Yeah.
yes. It's just like this contact, right? As soon as the timer instruction gets enabled, the done bit gets set. How long do we have the done bit? We get the done bit? Yeah. So it stays set, and then it gets de-energized, right? We still have the done bit until it times out. Good?
Yeah.
When do we get the enable bit? Anytime it's enabled. Anytime it's enabled. Yep. So anytime the rung has logical continuity.
And that's on the end and the end?
That's on both timers. That's on all timers.
All time.
Yep. This bit acts exactly the same on all the timers. The enable bit. It's just telling us that the instruction's enabled. How about the timer timing bit on a TOF? Yes, as soon as the rung gets de-energized, right? Because as soon as we de-energize, we start timing. Everybody get that?
So as soon as it de-energizes, that's when the time starts?
Yeah, that's when we should get the timer bit. Yep. Everybody good with that? Think of the old relay stuff. That's all I know. It works just the same.
So TOF and TON are opposites in regards to.
Yeah.
TT.
Kind of, sort of, but I wouldn't say that.
Starts timing on when it's energized. TOM starts counting.
Off. So turn on, off.
Yeah.
So the timer off, you'll have enabled and done at the same time. Or do you?
Enable and done at the same time.
And on the way off.
Yes. Yes, but that's a true statement. Except the done bit is going to stay for the time period while it times. The enable bit's going to go false.
And as soon as it times out, the done bit goes off.
Greenville Technical Schools will operate on a regular schedule on Thursday, October 11th. Please keep your own safety in mind as you make decisions based on individual circumstances.
There it is.
We're already here.
Thank you.
Oh, I don't know what the deal is. Piedmont Tech, Tri-County Tech, they're closed down, Greenville County Schools, Anderson County Schools.
Sink or swim.
So what you're saying is that you would rather us be out as well, so we can just go home. That's what I'm thinking.
That's what I'm looking for. You guys have Judy's class, don't you have Anderson's class after this? No,
I
really.
can go home. And sleep till 1 o'clock.
So you'll be that much further ahead of everybody when we get through this. If we get through this.
Timer on.
So are you guys good with this stuff? I hope. Let's take a look at, and we'll have some more lab that you can, to get you familiar with it. Let's look at, what was it, 7-5 we started on? Let's look at page 53 in your lab book. Page 53. Seven dash six. Let's take a look at 7-6. Is everybody on page 53 in your lab book? You see the contact, the 1 TD1 contact on that diagram? So we know that's an instantaneous contact, right?
Yep.
How does the instantaneous contact work and which status bit
Enabled.
does it work?
As soon as it's enabled, it closes.
That's exactly right, yes. So that's like the instantaneous contact. Everybody good? Does everybody get that?
That's only instant because of the fact that that acts as a ceiling. If there wasn't under the start button, it wouldn't be instantaneous.
It would be, because it acts just like a normal control relay contact.
Okay.
When the relay is energized, it closes, when it's de-energized, it opens.
So as soon as I got power, it closed.
Yeah.
Okay.
Yeah. Same way with the enable. Enable the instruction, it closes. Disable instruction, de-energize, open. How about the 1 TD2 contact?
That's when time flows into the done instruction.
So that's 5-6 minutes on right?
Yes, exactly right. Everybody understands how that works, the 1 TD2 contact? We energize the relay, and then it's going to time for 5 seconds, and then it's going to close for 5 seconds. Just like which status bit?
DN.
Yes, the DN. The done bit. Yeah.
So my done bit is like my own time to play, right?
Yeah. Consider that.
Okay. Is it always gonna be my whole time delay, or is it gonna be something different?
That's pretty much what it's going to be, yeah. Yeah. Of course, it can be used in the next IO also, right, which changes. Look, and while we're on that, let's turn over to page 54, 7-7. And we look at 1 TD1 in 7-7. How does that contact work in that circuit?
Which one?
1 TD1?
It's gonna be on,
10 seconds.
it's gonna be on while it's timing out.
That's right. It's gonna be on, it's gonna stay on for 10 seconds, right? It'll stay closed for 10 seconds and then open up. Which status bit is that?
Time.
Timer. Exactly right.
So the timer off the way.
It's still a timer on.
Timer on delay.
Okay, timer on.
Anyway, so that kind of lines it out for you. Which status bit, how it reacts, and how you can compare it to the hardwired, to the actual relay. Don't try to memorize it, think through it though, when you see it on a test. Just think through it, don't memorize this stuff if you can't. Your head will be so full that you will never remember a thing, right? Pretty much. And on to bigger and better things. GRAFCETs. On your desktop, there should be a shortcut to the IMT 172 folder. So open up the IMT 172 folder. It should be on your desktop. And you should see a folder called Mission Machines. Open up the GRAFCET. And we want to scroll down to pin 3. It's on page 3. So here's what I want to do. Look, I'm going to go, does everybody have this GRAFCET opened up? What I'm going to have you do, I'm going to have you leave that GRAFCET up on your desktop or whatever, and I'm going to open up the program for this, the PLC logic. And we're going to go through the PLC logic, comparing it to the GRAFCET, just so you understand how things line up. We'll be learning probably 3 new instructions today, too, while we're going through this. It's not real difficult. So anyways, the program, it's broken up into 4 different subroutines. You have the initialize, which is, that sets up the initial step on your GRAFCET. Step 0, that's the subroutine, that's the routine that sets that up, that's the main routine. And then a subroutine called inputs, that's setting up all the transitions. That's the logic that sets up all the transitions. A subroutine called outputs, what do you think that's setting up? The actions. Exactly right. And then I threw another routine in here called faults. Pretty standard, this is pretty standard logic. So now we're getting into some standardizing the logic and keeping things organized by your subroutines. And the logic is, it's latch, unlatched logic, it's step logic or state logic. Very, very, very common with conveyor systems, part sequencing stuff. If anybody has ever had a chance to look at any of the PLC logic where you work, and if you're around conveyor systems, you're going to see this real heavy. So I'm in ladder 2 right now, the initialize. And this logic, it's setting up step 0 or action 0 on the GRAFCET. Let's look at it. Standard start, stop, seal in logic. I'm using a binary, an internal relay. And then set up this manual and auto mode, just like we did a couple weeks ago. Kind of get you started in that. And here's actually where we initialize things. We have this move instruction. I know it's a little, you don't have a clue right now. The move instruction, it's a word level instruction. Meaning what? Yes, all 16 bits. That's exactly right. So you see, we're moving a value of 1 into B3 word 0. B3 is the binary data file, right? If I open it up, let me do that. To initialize this thing, we move a value of 1 into this entire word. Let me change it to decimal so it makes more sense. There's the 1, the value of 1 that we moved into word 0 of B3. Now I'm gonna change the binary. When we move a value of 1 into 16 bits, which bit gets set? That's right, bit 0, right? What if we move the value of 2 into there? Which bit would get set? 1. Yeah, 0, or 1, 2, 4, 8. It's the whole decimal to binary conversion thing, right? That's why that is so important to learn. And you thought, where will I ever use it? So it's 1, 2, if we move a value of 2, yeah, bit 1, right?
Yeah.
What if we move a value of 3 in here?
2.
So 0, I mean 1 is 0?
Yeah, yep. 1, 2, 1 plus 2, yep. We move a value of 4 in here. Yeah, yes. So we're moving a value of 1 to set up this initial state. Step 0. Bit 0, step 0. What else is happening here? It's moving a value of 1, but it's also zeroing out all the rest of the 16 bits. Because this is where all of our step logic, all of our steps, our actions are based on. And I'll show you that here in just a second. Yes, that's exactly right. Actually, let me go ahead and show you that. Here is B300, that's where it's being used. B301, step 1. See if I can zoom in. Bit 1, bit 2, of word 0. Bit 3, step 3. Bit 4. So we're setting up step 0 with that first move instruction. Everybody good with that? We're just initializing everything. So it's zeroing out all those other steps and only setting up for step 0. And it'll all come clear later on. And then we have these jump to subroutine instructions in here. If these weren't in here, ladder 3, ladder 4, and ladder 5, the PLC would never even know they existed. Because to get to them, that's the only way the scan can get to them, the PLC scan, is with that jump to subroutine instruction. Let's go, I'm going to go to the, here's where all of our transition logic is. So we start in step 0. We start in step 0. What's the first transition on the GRAFCET?
Long return. Reverse. Return, level shift.
Long return,
And start
trans return, return, and we have machine start. Everybody good? And then we get to action 1. This is our action 1. This sets up the logic for action 1. See what's going on there? So here's our transition logic. And then we get to action 1. We're in, right now, we get to action 1. We're in action 1, but then we have to make sure we unlatch action 0. And the reason we do that, we don't want multiple steps being active at the same time, because it would just confuse and mess things up. You understand? So you can't have, there can only be one step active at a time. Only one action active at a time. So we latch up step 1, and then we unlatch step 0. We're in step 1, but then we need to get to step 2, action 2. What is transition 2 on your GRAFCET?
Advancement.
whatever transit advanced
Advanced.
limit switch, yeah. Here's what's setting up that transition. And then we get to action 2. We're in action 2. We're in action 2, we have to unlatch action 1. So we got this latch, unlatch, latch, unlatch, and so on. We're still in action 2, step 2, and we need to get to step 3. What's our next transition on the GRAFCET?
Transition.
Long advanced switch.
Long advanced limit switch, yes. This is setting up our transition logic, and then we're getting to step 3. We're in step 3. We have to unlatch step 2, right? We don't want more than one step active at a time. In step 2, and what's our next transition here to get to step 4?
Turn.
Turn.
And return proc, yeah. Or limit switch, or whatever that said in there. Yeah. Same stuff. So I get the logic to get to step 4. We're in step 4. We have to unlatch step 3. And we don't want more than one action latched in. In step 4, and then what's the last part of, what's the last transition?
On return limit switch, traverse, turning.
Yes. Just like the logic, right? The PLC logic matches up with the GRAFCET. And at this point, you see what we're doing here. We're in step 4, but then when we return home, we have to unlatch step 4 because there's nothing left. Once we're done, we're done.
So you-
And
Does that mean that it relaxes step 0?
it should.
Oh,
That's a good point. Yes, it should relax step 0. Exactly right. If we want to just make this thing keep repeating. Here's the logic.
Otherwise, it doesn't run one cycle.
That's exactly right. Did everybody get that? Oh, yeah, the whole thing. This is out there in the 172 folder.
I can pull it out.
Yeah.
3 here.
Yeah, I'll prove this
So I
out.
can make a copy of it.
So, yeah, that was a good point. If we unlatch step 4, if we want to just keep repeating, then we need to branch around here and latch in step 0. You see what I mean? To start over at the top of the GRAFCET. Does that make sense?
no, say back around just the new 0.
Yeah, so we would do something like this, branch around and latch it. I have other logic that does this for us, that's why I didn't do this.
Oh, okay.
So we would latch up step 0 again.
So this is another B0.
Yeah, B30 would, yeah. And you see all these latch bits, you're saying, well, they're not doing anything. Here's where they actually cause the actions to work. Ladder 4 in the outputs.
Right here?
B01, that was step 1, right? What's action 1 on your GRAFCET?
And the main,
Motor forward.
Motor 1 forward, yes.
well, yeah. At the top, right?
Yeah. What was action 2?
Motor
Long advanced.
Motor 2 forward. You see where we're going with this, right? Here's step 1, and we've already taken care of all the logic in ladder 3 to run this thing. We're in step 1, we do action 1. In step 2, we do action 2.
Step 1, you do action 1, step 2, you do action 2.
That's right.
Okay, so,
Step 3, same thing.
alright, Now, so those are my outputs. So your middle of my transit monitor.
The middle part of this,
Yeah.
look at the addresses.
So the output.
Let me do this.
Is that like an
Is that like an interlock?
That's exactly what they are. Yeah, those are just interlocks, right? That's all they are. That's just interlock. Traverse forward, not traverse reverse. And then also this proc switch, traverse forward, so once we get advanced, it de-energizes the output. Once it gets advanced and makes a proc switch, it de-energizes the output. That's all, yeah. Here's the key though. Set up all your basic logic first, right? And then go back and add in your interlocks. Just get all your basic stuff just to make it run first, and then you can go back and start adding other things in. Step 3, that's what's setting up this action. Step 4, so everything pretty much matches the GRAFCET. Exactly how it's done. A couple more instructions we need to talk about while we're here. You see the MCR instruction?
Yeah.
That's the master control reset. Yeah. They're always used in pairs. MCR, they're always used in pairs. We have one, and what we're doing is we're setting up a zone with all of our outputs in it. So all of our outputs have to be inside this MCR fenced zone. Let's see if I can zoom back a little bit here. It's getting really small, guys. There's an MCR. And then here's an MCR down here, all right? Down at the bottom of all that stuff. So we're setting up a fence. What happens, and it works just like a master control relay. What happens, this rung has to stay energized in order for these outputs to stay energized. As soon as this rung goes low, as soon as it loses logical continuity, it de-energizes all the outputs, and the PLC or the processor quits scanning, stops scanning all this logic right here. So it works just like, and I know everybody should be familiar with this. I'm not going to spend a lot of time on this, but give you an idea. Master control relay. So that's your main power on relay, right? Or CRM, you'll see it in the CRM too, depending on the builder, control relay master. See what's going on there?
Yeah,
How's that working?
none of your stuff on line 2 and 3 is gonna work unless master control relay is on.
That's exactly right. We get an E-stop, it de-energizes the relay, opens contact. That way we don't have 120 volts out here on all this control circuit stuff, right? We get an E-stop. So, and that's doing exactly what we're doing here with this MCR instruction. Except Alan Bradley and their terminology, they wanted to call it a master control reset instead of a master control relay. That's what happens when you get a bunch of engineers in a group and start talking about things. start coming up with their own words.
Long names that don't mean a whole lot.
Ain't that right, this year?
Uh-huh.
So in effect, it acts just like an overload would in an electrical motor.
Kind of, yeah, but this is setting up a zone where all your output logic is. And what it does, it keeps that zone enabled. Yeah, as long as that one rung is enabled. And if you notice, what's the difference between the first rung, the first MCR rung, and the last MCR rung?
You have no window.
That's right. So the first MCR rung always has to be a conditional rung. Always has to be a conditional rung.
So if you have that MCR at the beginning and at the end, then you don't need to have, like, say, your little set of contacts that close at each single rung.
That's right. That's right. I have, yeah. If you get a fault, it's gonna
But just like before where you had the one set of contacts, you don't need to have that in
each.
anywhere else except at the beginning.
That's right, yeah. Let's see, another instruction, MCR. And now we can, let me show you something here, just so you get it. Do you see how, let's see if I can find it here. Let me do this. Okay, so right now, B301, it's latched up. Look at this B301 down here, the unlatched instruction. See that? Don't get that confused. Don't get it confused. When it's green, it's latched. When it's no color, it's unlatched. It's so, maintenance guys are horrendous for getting this stuff spun around in their heads for some reason. Well, that's latched and unlatched. How can that be latched and unlatched at the same time? It's not. It's latched. It's latched. So if you see
Will unlatch always have a green color?
only if it's latched up.
Only if it's latched.
Yeah. Yeah. So it's always going to be latched if it's green, if it's showing logical continuity. Let's see what else. There's another instruction, a couple of other instructions. So we had we have these JSRs, jump to the subroutine. Let me explain to you how they actually work. This says jump to subroutine, SPR subroutine file number is ladder 3. So we immediately jump into ladder 3. It's just like doing a call in the robotics world or doing a call in the Siemens world, if you're familiar with that. So we jump into ladder 3 and it sees this SPR instruction, scans ladder 3, and then it sees the return instruction. The return instruction takes it right back to the place it left off. So it's going to scan the following rung of where it jumped out from. That makes sense? The next rung is going to scan after it returns, it's going to scan rung 5. So we jump in rung 4, scan ladder 3, hit a return, and we're returning back to rung 5.
What kind of situation do they use calls? I mean, a call in this type of logic?
It's pretty common, yeah, just to keep things organized. So you have this piece of code out here running, right? And once in a while, we need to jump out to this piece of code and grab the data out of it, and then jump back into the main routine.
Well, I'm just trying to visualize, probably a piece of equipment that we work on, that we have that set up in, that's all.
Oh, yeah, I got it. Yeah, the jump to subroutine is just like a call.
No, it's in C.
Robotics.
I understand.
That way you don't have all of this stuff in one huge ladder program. It's organized into pieces. And it works great for like the maintenance guy. If he's having a problem, let's say he's having a problem with a motor starter, and he can say, oh, let's go to the outputs. And open up the outputs subroutine. Yeah,
What's the SBR?
subroutine.
Oh, okay.
Yeah.
Okay.
Now, I know you've been blasted with a lot of information, I'm trying to get through it, sorry. We have this SBR and the return instructions. Really and truly, they are not required. They're optional instructions. So they don't have to be used. I mean, it's going to jump into ladder 3 and continue scanning, but it's going to go all the way and scan every other ladder out there before it gets back to ladder 2. So you can see the advantages. It'll reduce scan time by doing this.
So
Because
it's
you
a
really,
stopgap, sort of?
yeah, you really want to scan all your inputs first, right?
Right.
Make sure the ladder program scanned all the input, all your input logic, and then go back to the main routine.
If we talk bottom left and right, it's going to go inputs.
Yeah. SPR, and really this, I say it's 100% optional, but it's set up, this SPR instruction, it's mostly set up so it's like program documentation. So that when we're looking through the program, we haven't written the program, somebody else wrote the program sitting at a desk somewhere. But when we're looking at the program and we come into this ladder, let's say we get into, we need to go to subroutine number 73. And it has an SPR instruction. And then hopefully they've done this. They said, okay, we jumped into this subroutine from ladder 53. That way you know what called that subroutine. Does it make sense? That way if you're troubleshooting, you can go back to ladder 53 and see what actually happened in ladder 53 that made it jump into ladder 73. Does that make sense? I know it probably doesn't.
It's like working.
It's telling you as a maintenance person, hey, I got called from ladder 2. That's all. Not enough of being overwhelmed, sorry. I try to put this stuff out here a little piece at a time, but it's kind of hard to do. Because right now, we're kind of at a point to where we have all this stuff coming together. We have timers, we have this step logic, we have latch instructions, with subroutines. So all of it's starting to come together. It's hard to just piece it in, piece at a time right now. So just hang in there. We'll get through. We're going to see it in action today. In fact, we're going to design, as a group, we're going to design a GRAFCET and then do the PLC logic for that GRAFCET. I think we need to take a break. Everybody's a little foggy.
A little foggy.
A lot of you probably have been foggy. I've been foggy.
Are we gonna do any time off?
And we are going on break.
Remember, I actually, I like
See you, Barbara.
We're rolling again. So now we're gonna take a scenario and design a GRAFCET, and then put together the PLC logic for that GRAFCET. We're gonna keep it simple. Keep it simple.
Okay,
There you go. There you go. Some of this stuff is real hard to keep simple, but I'm trying
Your
to
simple
do
might
it
be
in little
different than
pieces
my
at a time. So you get it. Do you remember the cylinder thing we did the other day? Cylinder? Yeah, we did a GRAFCET for, I think, maybe,
Whoa,
yeah.
okay.
Well, we're gonna do that. We have a cylinder. Retracted prods. Extended prods. Cylinder extended. Cylinder retracted prods that I'm going to abbreviate. And we're going to have a push button. We're going to start the GRAFCET. Where do we start? Which button? Yeah. Always start at the beginning, all right.
Home position.
Yes. Initial conditions, initial step. What's transition one?
Start.
Start,
And cylinder.
cylinder, retract.
Retract.
Yes, start push button. And
Cylinder, retract.
cylinder. Retracted prods. What's action one?
The cylinder extends.
Cylinder extend. Abbreviate here. Transition two.
Props too.
Cylinder extended prods.
Yes. Cylinder extended prods. Action two.
Cylinder retract.
Cylinder retract. And transition three.
Cylinder return.
Yeah. Cylinder. And we're back to the top. Now, we're not gonna, we won't set up that move instruction and all that stuff. We're gonna start as if we're in transition or action zero. Step zero. Zero. What's our first transition?
Start push button.
Start push button.
Start push button. What else?
And then the cylinder retract front.
Cylinder retract front. Is that all?
An action of.
Yes.
Cylinder
And
extended.
also cylinder extend.
Cylinder extend. And that's gonna be B301, step 1.
So that step 0 being used as you said, what, an enable?
It's just the initialized.
The initial?
Okay, the initial conditions. Yeah. We're in step 1.
Okay.
Yeah.
So the very first output is always going to be the latching action, unless you're turning something off.
Yeah,
Off would be unlatched, which you can turn off.
that's right. Yep, the very first part is always gonna be, yeah. What do we have to do now? We're in step 1.
The cylinder
Got to
extend,
unlatch cylinder.
the cylinder extend rocks.
Yes, we've got to unlatch this, don't we? We don't want 2 steps active at the same time. Unlatch, step 0. We have to unlatch step 0. We're still in step 1.
And then cylinder extend rocks.
Cylinders and props. Yep,
And then the output cylinder retract.
yes.
So that'd be last, right?
Yep,
Yeah.
that'll be a latch. Yep, we're just setting up our transition 2. B302, step 2.
And that's the retract position of the cylinder?
Yeah.
Yeah, cylinder, yep, so that's our body to retract the cylinder. We're in step 2, what do we gotta do?
Unlatch step 2.
Yeah. Step 2,
Switch into unlatch, what, 1?
yeah.
B301.
That's right. Unlatch step 1, B301. We're still in step 2.
Cylinder return
Cylinder
rocks.
retract.
Cylinder return. Oh, gotcha. And we're returned back home, aren't we?
Yeah.
Now we need to unlatch that last step. Since we made it back home, we
Yeah.
have to unlatch that last step. And,
Unlatch B302.
yeah, yep, that's right, 302. And we can also, like I think Aaron mentioned earlier, we'll latch up,
B301.
yeah,
000.
0, yeah, step 0. We're going to finish out the logic here in just a second. That's all of our transition logic. So we're good with that. Make sense? Pretty easy to follow. Latch, unlatch, latch, unlatch. We're just setting up our transition logic. That's all we're doing. We haven't gotten to the action logic yet. This is all of our transition logic.
I was going to do that again.
Okay, I'm gonna leave that, and then we're gonna do our action logic.
You put, where it says step 0, that was supposed to be step 2.
Oh, thank you, yes, that's right. I raised a couple of these step codes. It has to be step 2, right? And now we're gonna do the action line. What's that gonna be? We're doing our action line.
Your stop move?
We'll disregard the MCR stuff for now. We're just gonna do the logic that actually drives the output. Action 1, right?
Yeah,
Well, with action 1, what's setting up action 1 over here?
3, 3, 0.
Your start button.
Select action.
That's setting up action 1, right?
Mm-hmm.
Step 1? Step 1. And this is our real world output. Output 0, 0. Cylinder extend. Now what? Solve our action logic.
Then just do,
Still need to be
track.
on step 1 to unlatch.
Yeah.
Do we need to unlatch? We don't need to unlatch anything, do we? Because we're all doing that over here.
Oh, the you would do the.
Yeah. Step 2. Yeah. So here's where all of our action stuff is. We've already set up all of our logic to make all of this happen. Uh-huh.
Would it be?
Retract cylinder.
It'll be
That's good.
0s.
Yeah, some literal output. I put 1.
And that's it, right?
Pretty much
Only
it.
2 actions.
Now,
Yeah.
Only 2
now that we have our basic logic done, now we add in our interlocks. So now it'll run the way it is, but we gotta add in our interlocks for this stuff. That's a 1, but
2 on top, 1 on bottom. But that'd be close, right? I mean, it's not over different.
oh, and that's 0, 1.
Only sit on the.
So it's only changing.
This is our real world output, and all we do is, so in our steps, we use the binary. Step 1 is bit 1, step 2 is bit 2, yeah. It would be ideal if we could do it that way though over here. That way, that's exactly right. If you had plenty of I/O, you'd do it. Now we add in our interlocks. Now we have an interlock here, we have an interlock here. What's the address of this interlock going to be?
Step 2. I get it.
Output.
Feet 3, 0.
Yeah. So we need to interlock it with this address, right?
Oh.
So if this is on, this is on.
That'd be 1.
Yeah,
And that bottom would be 0, 0.
yeah.
Okay, good day.
0, 0. Yeah, that's the idea. And there's 2 more interlocks that we can add in too. That way, we have this stuff set up, the logic is bulletproof, right? Anything can happen, it's going to stop the machine. That's the whole idea. That machine will run without the interlocks, but if something happens, it might just keep on deciding that it wants to just keep on running, even if there's a safety problem. So, we add in additional interlocks. What are they?
Now would that be?
A bit low.
Yeah, so this will be the cylinder extended proc, right? Whichever.
B301.
The cylinder extended proc. See where I'm going with this?
So the bottom will be the cylinder extract process.
Yeah, cylinder.
Can you elaborate on it a little bit more, Carl?
Yeah. You understand how these interlocks work, right?
Yeah.
So one solenoid's on, the other one's gotta be off. Well, these interlocks work so that we extend the cylinder out, right? Once it makes the proc switch, it de-energizes that output. Once the proc switch is made, showing that it's extended, then it de-energizes the output. Does that make sense?
That way it doesn't come back and hit you with something else.
Right, or just keep driving, and so on, yeah.
So once it's made on the other logic, then it'll trigger that.
Yeah. Yeah, it makes your logic foolproof. If anything can happen, and it's gonna stop the machine, right? So, yep, it'll work, but without that stuff in there. But then one day, something decided it wants to take it, you know what? And he said, I didn't say it. We're all adults in here. Now, we're gonna take this. Now we're gonna actually do a program. So everybody open up RS Logic. Do a new project. Does everybody have this project?
Okay, you think of that, the spider, the one you just.
Okay, RS Logic. Right now, you see, look at the program files in the project tree on the left. How many program files do we have?
File two, just one.
Yeah, we have three, because two of them are system files, and we have ladder 2. Let's go ahead and rename ladder 2. Right click, rename.
Rename that too.
Yes. To initialize.
Initialize.
Initialize. I can do SINIT.
Initialize. Is this initial line or initial line?
Initialize.
Initialize.
Like initial?
Initial division. Now, let's go ahead and add a couple more ladders. Right click on program file. Say new. And ladder 3, name it inputs. Let's do another one. Right click on program file. Ladder 4, name that one outputs. Right click on program file. Ladder 5, let's do a false subroutine. False.
Whoa, can you lost me.
Okay.
What was third?
Initialize inputs, outputs, and false.
3 and reject. Does everybody have initial items with letter 2, 3, 4, 5? Good. Let's, in ladder 2, you should be in ladder 2 right now. In ladder 2, go ahead and insert a few rungs. Just hit the insert key on the keyboard, do it easy. Yeah, do it the easy way. Insert key on the keyboard instead of having to drag or drop and all that stuff. I like shortcuts. And go ahead, we're gonna do a seal in, start, stop, seal in here. Just a normal start, stop, seal. Once you get to this point, hang tight for just a second. I know most of you are already there. Once you get to this point, actually open up the binary data file. Binary data file. B3. You see we only have one word of binaries in there. Click on properties. And let's go ahead and bump up the number of elements to 5. If I can go to 255, that's going to give us plenty to work with. Go ahead and exit that, just to expand that file. And now let's go ahead and do our seal-in circuit. Using our traders, I00 is going to be the stop button. And the output is going to be B310. Let's just call it a master control start. Yeah, B310. Because we're going to use the word 0 in all of our steps, and we don't want to be playing in that. B310. Good, yeah. Now, we've got to set up
You can
the logic for that initial step. So we use an XIC, and the address for that first pass, it's not magic, guys, it's S:1/15. I'm going to show you exactly where to find that if you ever forget it.
We find it.
It's in the status file, S2 status file. If you open that up, see it says first pass bit, S:1/15.
Oh, and it automatically names the first pass.
Yeah.
Oh, okay.
That's the data file. Open that up. That's where the address is actually at. Which you can call it.
Sorry, hey, you don't know any password to drag it over there?
No, not that one, yeah. And now we got to grab a move instruction. You get a cursor over in this instruction palette. It's in the move logical part of this thing. Move logical. And drop in a move instruction. MOV. Yep. And the source value, we're just going to put a value of 1. Sort of.
Oh, look, go back. Will you get back down?
Drop in a move stuff.
Yeah.
Let's do B30.
Destination?
Uh-huh. And the GRAFCET steps. And while we're here, go ahead and insert, let's see, reruns down at the bottom. And we need to grab a JSR. That is in program control, if you can find that. It's to the right of that move logical.
You said to add what? To GSR?
Program control JSR. Yes.
And it's also in move logic.
It's in program control. It's like to the right of moving logic. And it says it's asking for the SBR file number. Type U:3, and it'll only accept the colon, the semicolon doesn't work. Let's see. Line 3, the description is going to be input logic. Well, we could name it transition logic too. That would probably make better sense. Go ahead and drop in 2 more JSR for U4. Output 1. And fault logic. And when you're done, let's open up ladder 3. Ladder 3. Insert some rungs.
Do we need to save this or anything?
I would say yes. That would probably be a good point to save this thing.
Where are we gonna save it under this?
Cylinder. You know what?
So do we have to close this open ladder 3?
No.
No.
Okay. I mean,
We gotta do, save as, put it to
Everybody get saved? Ready to move on? Moving on. So in ladder 3, rung 0, we need an SPR instruction. It's in program control. And we need to put an OTE output of that instruction. B320. B320, jump from ladder 2.
F320.
Cylinder.
Where the SBR?
It's in program control.
Program,
Yeah. You know, if you want, if you go, view, there's an instruction palette, it'll bring this thing up for you. This thing gets in my way and I don't like it. Some of you might like it though.
That's why.
But you can find all the instructions right there if you want to do it that way. View and instruction palette.
This is, oh, down here, did you run it off? That's showing as this.
Two sections.
On a jump like that.
That's right.
One quick question, Mr. Hammond. When we go to save this one, we're gonna save it in cylinder also?
Yeah, once you click the save project, it's going to save everything anyway.
It's not gonna overwrite what's already in there?
Because we'll want to save the whole, all of our resources.
Correct.
Yeah, that's one project. Okay. Good. Everybody have SBR up there? Okay, good. And now, we're going to start our transition logic. Where do we start?
Step 0.
Step 0. B300. Good. Initial step. Step 0. Yeah, it'll name it because we named the whole word.
Did it do that automatically for you?
It'll name it step logic because we named that whole word.
It should be B30/0?
Yeah, 30/0. It's gonna put a name on it, but you can also put a name on that bit because
Mine's got GRAFCET steps. Is that?
yeah, because we named B30, whole word. Just rename that instruction. That's right. Yeah, you got it. You got a street name called GRAFCET Logic, and you got a house number called whatever, house name called initial step. So step 0. We've got to get to, so we're setting up the logic for transition number 1. What's transition 1? Start. And I think it was, I don't remember what I called MCR, but yeah, master control start. So we'll use our CLN piece of logic in this. And the other part of the transition is retract or something.
What was the address for that? P320?
Go ahead and I02. That's going to be that cylinder retractor box. GRS1. been an OTL, output latch instruction. 301.
Can you hold on just 1 second?
Okay.
Okay, on the first one, that address was B30/0.
Yeah.
And that's initial step. B30 where?
See that from back here?
I can't, I'm half blind. But
Well, you gotta see that. Well, I guess
Okay,
you
this
can.
one's master control is 301.
Everybody gotta run a lot.
We not,
You've been doing this for years.
I bet you wanna go to sleep with me from the class, huh? Like, I was doing this for 20 years.
Get that with every class.
Especially you, especially you. Oh, sorry.
Okay, does everybody have a run of logic in here?
Yeah.
Okay, we are flying on. We're moving on. Yeah. So we're latched up in step 1. Now just use your shortcuts, don't try typing that stuff in, okay? Use your shortcuts, drag and drop. And we gotta unlatch step 0, right?
Yeah.